Good morning. Thanks for sticking with us. How was the party? Good?
Or did it rain too much?
Thanks for getting up and coming along this morning to come and hear about modern data warehousing on Azure. I'm Ben, or Benjamin, and this is Simon. We're both solution architects in Microsoft Services, so we work in the customer-facing side of Microsoft, have a strong relationship with engineering, so we use the feedback we get through customer engagements projects to feed that back to engineering. We both work in the CTO office for data and AI, so we focus primarily on data platform, advanced analytics. Just briefly on the Microsoft Services Organization, because not many people know that Microsoft has a services organization. So we have 22,000 employees around the world. It's a combination of digital advisors, which are similar to business architects in capability, solution architects, data scientists, and premier support engineers. So quite an interesting mix and profile of skills.
And we work a lot together with partners as well, so help out and work together.
Absolutely, absolutely. So, what is a modern data warehouse? Everything is modern today. We have modern architectures, modern applications, and we have modern data warehouse. So, looking at the research and the estate, there's a number of attributes that we identified of a modern data warehouse. And these are taken from research, academia research, industry research, but some of the primary attributes. So, integrated, so it's flexible. You can integrate with multiple data sources. You're not just confined to relational schemas. It provides near real-time capabilities, so you can support streaming scenarios, whether that's from stock systems, social media, etc. Advanced analytics capabilities, so now we're seeing data warehouses infused with ML capabilities like we're seeing in the SQL Server platform, in the data warehouse platform, etc. Highly performant and highly scalable, so dynamic elastic scale is highly demanded. Simon.
Yeah, if you're old like me, you have started working with databases since a very long time. So I started working with SQL Server in 1999. And this is data on the evolution where we came from. When I started at Microsoft, a large database was like 100 megs. Customers called in, I have a 100 meg database. Wow, that's big. And this is TPC from 99. You can see the evolution on the query performance per hour, so the number of queries that they can do in the tests, and the scale factor, the size of the database. So a huge evolution has happened on this side. And this actually is why modern data warehousing is so important and so interesting. Because now with these enhancements that we have in the different products, and also with the cost effect, now for the first time, companies actually can afford to store all their data for all eternity. Before, the biggest problem when you build system was, how do I get rid of data? So the key thing here is to make sure that our architectures that we create actually supports customers so that they can take advantage of the scale factors, take advantage of the cost savings that you have in new storage systems. I mean, it used to be very simple when you had data warehousing. I mean, it's like you had a single source. Data warehousing was really about connecting to your ERP system, getting transactional information out of it, getting financial information. So building a data warehouse was, okay, I built a simple schema. I mean, maybe not so simple. If you connect to ERPs like SAP, you probably ended up with hundreds of tables anyway. But it was still relational. Now, the problem that we have today is that the relational sources is not the only sources that we have to take care of. We have varied sources. It's like different types of devices that send in information, different type of social media feeds that needs to get inside the data warehouse correlated with the data. A large project that I've been working with has been on how to manage IoT devices. We're talking about thousands of machines in factory environments with hundreds and hundreds of sensors sending in values as often as 20,000 times per second into a data warehousing environment. And that is a single machine. So if you have 5,000 of those, you can imagine the scale rates that you need to take care of. So what does that mean? Well, it definitely adds complexity and cost. So that is something that a lot of our customers are feeling. This is a big challenge for us. How do we actually make sure that we get an architecture that can work for these types of environments? The other thing that is clear when we speak to customers is that we have a lot of customers that are confused. So Ben and I, we worked in the expo hall earlier this week, and we were standing there in the Databricks booth. And you had people coming up to us and say, like, what is this Databricks? You have Data Lake, you have HDInsight, you have Cosmos DB, you have SQL Data Warehouse, SQL DB, and then you can use all the other partner solutions. And now you also have introduced this Databricks. What should I use? When should I use it? And that is a common question that we often get from customers, because there is not a single way of building a modern architecture. Now, another thing that has changed as well is that, like, all data has value. In a lot of the use cases when we talk about machine learning, when we talk about the new type of workloads, it's like you don't know what's going to be valuable. I mean, in the past, it was simple. I got my financial transactions into the data warehouse. That was it. That's what I needed. I needed to do financial reporting. Now, customers come to us and say, all data may have value. So in the case that I said, that I told you about the IoT scenario, they don't really know what's going to be valuable. They want to do predictive maintenance, understand when machines are going to fail. They have no idea about the patterns that they will see. So what they're trying to do is data hoarding. So they say, okay, we will get the data in, we will store it indefinitely, and then we will analyze it, see some result. Hopefully they are valuable. If not, we're going to analyze some more and hopefully get new results. And this is going to do. Now, that makes it actually a bit hard, because if that's your strategy, conforming to a fixed schema gets hard. Because if you're going to store things indefinitely, the source systems will change. The data that they will send in will change. So deciding on how your dimension tables should look like, if you work in a star schema, is quite hard. So what customers are doing is that let's store it in the native format as it was sent by the source system. Store it in that way, and then when we read it, let's impose the schema. Let's decide then that I'm interested in the 3 first column and then the 10th column, or this part of a binary value. Because that allows applications and users to interpret the data, to understand when and what data to actually use.
So the best question I had yesterday in the expo hall was, what's Azure? And I was like, how long have you got? So this is the primary components of the Azure data landscape as we see it today. You can understand how it can be quite confusing in terms of what do I choose, what are the scenarios, how do I distinguish between Databricks versus HDInsight, should I choose a SQL Data Warehouse? As we add more services and products, more guidance is needed ultimately. And that's certainly the trend we're seeing when we talk to our customers. So the modern data warehouse landscape is actually a subset of these components. So we're talking about, from the ingestion point of view, things like event hubs, Azure Data Lake, the storage and transformation and the representation of the data back to the end users through things like Azure Analysis Services, which is highly performant multi-dimensional engine. So if you've got existing OLAP cubes on premise today, Analysis Services is a great solution for you. And then we have things like Databricks, which is serverless Spark ultimately under the covers, which allows you to massively auto-scale and provide an interface for your data scientists. So as you can see, number of different solutions, number of different streaming solutions. We've got Stream Analytics, we've got Spark streaming. How do you choose which one and when? So building your modern data warehouse is not just a case of choosing one service, it's typically a combination. To try and kind of put some structure around this in terms of the framing of the components in the modern data warehouse platform. So what you see here on the left is the Azure Marketplace. So we have things like the IaaS clusters that you can deploy. So Hortonworks sandbox environment. It wasn't long ago I was talking to a customer in the UK actually who had an on-prem Hortonworks cluster. They were using things like Apache NiFi, which is a data pipeline framework, and they wanted to lift and shift that into Azure. So they basically, wanted to make the decision of deploying their own IaaS servers and moving Hortonworks onto that. We also have Azure HDInsight, which is Microsoft's implementation of Hadoop using the Hortonworks distribution. Allows you to choose your cluster types, control over your nodes. We've just released new services and gone GA with enterprise security, so you can use things like Azure Active Directory, Apache Ranger, which allows you to put policies on the Hive tables, which is a really requested feature. So continued investment in HDInsight is coming along. We've also added things like Apache Druid, which gives you fast indexing on top of the HDInsight data sets. And then in the middle, we have Databricks. Lots and lots of interest in Databricks, as you can imagine, given the boom in AI and data science. We're seeing a common trend, certainly in EMEA, in terms of the adoption and interest in Databricks. We're seeing it baked into RFIs and RFPs, interestingly enough. So it's becoming like the default big data science platform. As we go along into kind of control and configuration, we've got Azure SQL Data Warehouse. So this is our petascale MPP service. So we're replatforming today a lot of organizations from things like Netezza and Teradata and Oracle onto our Azure SQL Data Warehouse appliance in the cloud. And finally, we've got Azure Data Lake Analytics, which is the job service that we provide on top of Azure Data Lake Store. It allows you to write USQL queries. So anyone familiar with T-SQL can write ADLA queries. So this is meant to give you kind of a framing and a positioning of the modern data warehouse capabilities. Simon, is there anything you want to say?
Yeah, so I mean, it's like the important thing here is on the access that you have, the control and configurability. So the biggest control and configurability is on the IaaS cluster side, because you can basically decide whatever you install. I mean, you get RDP or SSH into the VM, and you can basically configure it and install whatever you want.
Yes.
And then at the other side, you have the Azure Data Lake Analytics, where you have no control over the environment. That's basically nothing that you can do. You can load in some libraries that you write, but that's it. But it also is on the reduce of the administration on the other axis. So if you install stuff yourself, you need to maintain it. On the other hand, Microsoft maintains it. And basically, that's how it is. You still, even though that we maintain Azure HDInsight, you still have to administrate your clusters, but there are less administration than the IaaS clusters.
How does the new SQL Server Kubernetes stuff go inside here?
So question was, how does the new SQL Server Kubernetes clusters goes into here? We have focused on the things that are available today in production. The other thing that we have focused on is on the scale-out scenarios, because in a lot of the other, so normal SQL Server, you can do scale-up, but scale-out is fairly limited or hard to do, while this can do scale-out to infinite data sources. Good question, thanks.
Yeah, you will notice that we intentionally haven't put things like SQL Server and Azure SQL Database on here, because the trends we've seen is using those services primarily as operational data stores, transactional systems. So we've tried to position these services as the data warehouse services ultimately.
But that will probably change with SQL Server 2019 and the new query capabilities that you have
And the big data cluster,
across different solutions. So, yeah.
So taking that one level down, we tried to provide you with some level of decision tree. And we took feedback from a number of organizations, customers, and looked at the kind of requests and the use cases. And we've tried to form this picture to give you an idea of when to go, where to go and when. But as you can imagine, it's not always a case of one or the other. You might have use cases where you need to use Azure SQL Data Warehouse with Azure Databricks. That could be quite popular scenario. So data scientists might engineering Databricks, do the feature engineering, exploration, and then they might persist the data frame in Databricks out to Data Warehouse. That could be an interesting concept. So if you start at the top, do you need scheme run read or scheme run write? Well, if you need scheme run write, go to Azure SQL Data Warehouse. Gives you the ability to define your dimensions and facts and distribution strategy. Do you require OSS framework flexibility? So this kind of takes you down the route of, do I need the IaaS clusters with control over what I'm deploying in terms of Hortonworks distribution, Apache frameworks, or can I take the Databricks route and have a managed cluster where a lot of the service is controlled and deployed for me under the covers? And on the right, we've got Azure Data Lake. So do I need interactive streaming or batch? If batch is okay, SQL might be a good fit. It's a job service, low administration. Anyone familiar with T-SQL? So organizations where there's a lot of analysts, T-SQL is familiar to them, then the SQL job service might be a good fit. So we're continually evolving this picture as new services come along and the decision tree is evolving, but we'd love your feedback. There's any kind of other decision points. So yes, this is kind of work in progress for us. In terms of data warehouse planning framework, I've got a couple more slides and I've got some demos, promise you. Data warehouse planning framework. So in terms of the conversations we have today about data warehousing and how do we approach this, we've got an on-prem server, cluster, we want to move to the cloud, what's the strategy? These are kind of the core pillars, the process we go through ultimately. So looking at things like what are your non-functional requirements or quality attributes in terms of scale, performance, what are your cost budget boundaries, so we can predict in this new consumption world how much budget to request each fiscal for the services. What's the architecture blueprint as a principle and a basis for our workloads? And then how do we go about monitoring capacity and cost and usage? And what are the processes and procedures for that? So some of the phases we go through, and these are the common pillars that we see today.
I would like to add, the key thing here is start with the business case. Where we see customers fail is when they start from the technology side.
Yes.
I've been involved with a number of customers that say, oh, I want to build a modern data warehouse platform having a data lake. And my first question is, why? What are you going to solve for your business? And in many cases, they don't know. They see it as a technical exercise. Well, everybody else has one. We need to have one as well. Or I was at a trade show. Somebody said that this is the thing you should have. So we need to have it in our architecture. And in many cases, that it becomes a very interesting technical exercise. But it's just spending money and creating an architecture that in many cases won't be used unless you have the business case for it.
There are a number of incidents where we've walked into scenarios where it's like, we want Microsoft Machine Learning Server. Why is that? We just want it. Everyone wants R, but it might not be suitable for the use case or workload. So we're trying to shift the conversation rather than have a product conversation ultimately. In terms of capacity planning strategies for data warehousing, these are 3 approaches. They actually come from marketing background, but it's an interesting way to frame and understand the data warehousing strategies. So LEAD is all about forecasting or predicting your capacity that you require. So conducting scalability tests, benchmark tests. For things like HDInsight, there's a Hive simulation framework available on GitHub. Have I got the link in here? I'm sure I'll put the link in somewhere in one of the decks. There's a nice, interesting simulation framework you can use to scale test and forecast workload requirements. Because often, you know, a typical question would be, how many nodes do I need? What type of nodes for my HDInsight Hadoop cluster or Databricks cluster? And you need to be able to think about how to scale, get an idea of workload, and influence the cost decisions you need to make. In terms of lag, this is all about responding reactively to scale capacity demands. So you might get an alert through the Databricks console saying your job's consuming all the storage on all the nodes or all the capacity, all the cores. There might be an alert, and you go in and add more nodes, scaling that out, or create a new cluster. And the final one is match, where there's this proactive response demand scenario. So internally, we use a lot of HDInsight clusters as well as Databricks clusters, but we have a number of procedures in place to monitor things like the yarn schedulers on the HDInsight cluster. So it can execute scripts to actually scale out that cluster when needed. So these are 3 kind of core capacity planning strategies that you might find useful as a basis. So in terms of technology choices, we're going to cover 4 of them here. We've got Azure Data Lake, Azure SQL Data Warehouse, HDInsight, and Databricks. So I'll quickly go through some of these, and then I'll jump to the demo. So in terms of Azure Data Lake today, it's made up of a combination of Azure Data Lake Storage, Azure Data Lake Analytics. And this gives you an idea of the serverless nature of the data lake topology. Developers typically interface through things like Visual Studio, where you can define your USQL scripts, store it in source control, Azure DevOps, assess your job service requirements, and execute the jobs on the cluster. Your data persisted in Azure Data Lake Storage, which gives you the ability to control permissions on the files, so POSIX type security requirements, execute permissions, read permissions, which is very appealing in a data warehouse type environment where you want to have that granular level of control on the file system. Simon, is there anything else you wanted to add on this data lake?
Well, it's like what we see is most customers are shifting away from data lake. And the reason for that is that the extensibility is not as great as you have in the other technology choices that we will show.
Yes, good point. So HDInsight, is anyone using HDInsight or Data Lake today? Okay, that's good to know. So HDInsight is Microsoft's implementation of Hadoop on Azure using the Hortonworks distribution, as I mentioned earlier. As a concept of nodes, so when you actually set up the HDInsight cluster, you provision your data nodes. There's 2 head nodes typically. But what it does give you is the ability to control and log on to your cluster nodes if there are any issues. So one scenario I encountered was running Hive queries on a 36-node HDInsight cluster in Azure. The query failed, so I had to log on to the data nodes directly, and it turns out that the temporary storage wasn't being cleaned up correctly on the data nodes. That was quite an interesting scenario where the flexibility of HDInsight allowed me to go down to that level, gave me a lot of control. So, you know, I had to actually execute some HDFS commands and clean up the storage on the nodes, and everything was back to normal. But it's it has, now we've got Databricks coming along now. There are some questions around, should I go for HDInsight or should I go for Databricks? And you have to look at the capabilities of both because they are not equal. Given some of the features and capabilities that we announced with the new preview of the HDInsight service, so Apache Druid and TensorFlow support on the HDInsight cluster, the enterprise-grade security, bring your own encryption for Apache Kafka, and then when you're looking at the Databricks side of things, you've got support for Scala, R, Python, Sparkly R, Jupyter notebooks, whereas you've also got Zeppelin notebooks in HDInsight. So you have to look at the requirements of your organization and the use cases to work out which route to go ultimately.
The other technology choice that you have is SQL Server, Azure SQL Server Data Warehouse. So what we have done here is we have a scale-out version of SQL Server where you have a number of compute instances that you could use. And basically, to them, the databases or the data files are attached, which means that you query and the query is actually distributed across the different compute nodes. So you send the query into the single instance, but beneath it, you have several compute nodes that execute the query. How many is dependent on the number of DWUs that you define on your Azure SQL Data Warehouse. The good thing about this is that you actually have the possibility of, since we have decoupled the storage and the compute, you actually have the possibility to pause compute and scale up and scale down compute as necessary. So in a lot of cases, when you move to a modern cloud-based data warehouse, what you need to start to think about is your usage patterns as well. So do you really need to have your SQL Data Warehouse cluster running 24/7? Or are you actually only using it to do your ELT or ETL and then load your analysis services models or cubes and then nobody accesses it? Well, in that case, you only need to run it while you actually run your ETL jobs and your loading jobs. The rest of the time, you can pause it. So it comes down to your planning again. It's like, when do I actually need to run it? The other thing is with Azure SQL Data Warehouse, you have SQL compatibility. It's not full SQL. There are things that doesn't conform to what you would be aware or familiar with if you are a SQL developer. So there are no foreign keys constraints, those things, because of the distributed nature. Because a single compute instance, if you have a distributed table, will only have part of it. So dependent on how you set up your distribution, it may have different parts. And also, since you can scale it up and down, if you run on a small set of DWs, the node in behind will actually have more of the data, as opposed to if you run with a large set of DWs, the node will have a smaller part of the data. So what this gives us is the capability to do scale out and run queries across terabytes and petabytes of data in a very, very fast fashion. Now, it is built for batch workloads. So if you're looking for interactive querying for that, then we need to start to think about how you actually do your architecture around caching. Question?
Is there a role for data lake storage in this particular solution?
So the question is there a role for data lake storage in this specific solution? So if you choose a solution that only consists of SQL Server, Azure SQL Server Data Warehouse, no, you wouldn't have that. But as you will see in most of the architecture diagrams that we will have later, that may not be the case. You typically would have a combination of the services. So as I said, so what we have the ability to do is also the caching on the machine, so that you actually can then access the information in a very fast way.
One more thing is in the announcements around the Gen 2 DW service this week, we've announced the inclusion of the MVM Express storage, which actually, from the benchmarks that have been conducted, is providing 5 times more performance gain over SSD. So have a look at the Gen 2 DW announcements as well. It's worth doing.
Good point. The next one from a technology perspective is Azure Databricks. So Azure Databricks, it's basically you have the Azure Databricks UX communicating to the control plane. You spin up your cluster. It basically is a number of VMs in a blob storage, or a number of VMs in a VNet, and then connecting to your store. So basically, what you have the ability to do is you create this workspace, you run your cluster, connect it to the data source that you want to do, and you can run your Spark SQL queries, your Python, your Scala jobs, your R jobs. This based on DBFS, which is an evolution of HDFS. So it's Databricks file system. So everybody has to do their own file system. Now, but and the thing here is that there is actually, so they've done some smart things in it. So it's not just a file system for the file system's sake. They actually get better performance compared to Spark, which is kind of neat because it is Spark. So it is a good thing. Now, here you also have the decoupled nature of decoupling between the compute and the storage. So when you create a Databricks cluster, you have the possibility to specify how long it should be running for. So should it be run for 24 hours, or should I terminate it after a certain time of inactivity?
Just go back one slide, sorry, Simon. 2 important things as well I need to call out about Databricks, which has got a lot of interest at the moment. One of them is Delta. So Delta will provide ACID type capabilities, transactional type capabilities on a Databricks cluster. So the ability to allow read and writes at the same time, statistics on your data sets. So Delta is really appealing in terms of providing data warehouse type capabilities on a Spark serverless Databricks cluster. Delta also supports things like compaction, so you can actually compress your data quite a lot as well.
Yeah, I forgot to add as well, the Databricks control plane actually also gives the capability of on-demand scaling. So basically, it will monitor and see, do I need to spin up new VMs? So when you create your cluster,
Yes.
you can decide, you can start small and then have it grow automatically and shrink automatically.
And the second thing I wanted to mention, there's probably another one actually, is MLflow. MLflow is really interesting for data science type scenarios. So MLflow is I believe it's in beta, might be alpha, but it's a package that allows you to provide lineage and traceability on ML models in Databricks. So it will capture things like what the change in accuracy and precision of my model over time, how many executions were invoked. So MLflow is really interesting as well in terms of providing a level of audit on your ML scenarios. And the third one is for Databricks, is the integration really. So it's not just a Microsoft story on Databricks. So Azure Databricks will allow you to integrate with things like Tableau, Alteryx. There's a number of different third-party services that you can use in terms of BI tools. And then in terms of data source connectors, it's pretty vast. I mean, you're talking through things like CSV, JSON, and number of SQL data sources, etc. So those are three important things I wanted to call out. Which brings me on to the demo. So I think we've had enough slides for a moment. Let's switch to the demo. So let me just flick back for a second. Can I just borrow the clicker, Simon?
Yeah.
Thank you. So in terms of the demo, what I'm going to show is Azure Databricks cluster, preparing a data frame, and we're going to persist that into a SQL Data Warehouse repository. So it's showing you a level of integration. So ultimately, I'm showing you the prep and train of this modern data warehouse topology and serving up that data set, the data frame that it's called, into SQL Data Warehouse. So let me just switch to the demo. And hopefully live demo works. So let's see. Okay, it's good. Right, so in this demo, I've got some data that I'm stored in Azure Data Lake store. Let's just wait for this to come up. Okay. Data Explorer. So it's a very simple JSON file I've got here. Some radio data with names in, as you can see here, JSON file. So not very complicated data set. It's got things about users and gender and location, etc. So that's my source data set. What I want to do is process that in Azure Databricks and actually serve it up into SQL Data Warehouse. So one of the cool things we announced this week was the Data Warehouse connector for Azure Databricks. So the scenario is the data scientist is building the data frame in Databricks, done an exploration, now they want to push it out to the data warehouse for an analyst to consume. So in my Azure Databricks environment, you'll see it's got the familiarity of the Azure portal. I have a number of notebooks here. So the first notebook I'm going to show you is this one. So this is my Jupyter notebook. So everything I'm showing you here today is available externally as a tutorial, but I'm just going to kind of step through it. There are some steps you need to do that I won't show you here, which are things like making sure you get the tokens and the service principal IDs of your Azure Active Directory. And the first step here is what that is talking to. So you need your service principal credentials. Now, typically, you wouldn't actually store secrets inside your Jupyter notebook like username and passwords. For the purposes of the demo, that's what I'm doing. But in a production scenario, you would use Azure Databricks Secrets, which allows you to use things like Azure Key Vault to store your usernames and passwords, for example. Okay. So this is providing my credentials. Let's just run this. Okay, that's really quick. In terms of reading the data set from Azure Data Lake, this is really quite straightforward. It's a SQL read, JSON read, and I'm reading the JSON file, okay? So let me just run this. Actually, let me just clear the output of that. Results. If this works. It's quite a nice tip if you've got a Jupyter notebook and you want to clear the results. I'll just go into the dev console in Edge or Chrome and just do notebook.clear results. If you can just see that here, this is quite a nice thing. Right, F12. When it comes back to me, so I want to read the JSON file. Okay, so what you see here. It's read the JSON file, it's returning a bunch of attributes and data types. If I actually want to visualize that data set, data frame as it's called, df.show and returning your data set in a tabular format. So data scientist looking at his data set, is very happy, all is good. If you want to visualize specific attributes, it is simply a case of providing them in a select statement, as in the data frame context. So this is a Scala language, and you're just providing a list of those attributes to return in the data set. If you want to change attributes, again, relatively straightforward. So you do a rename. So I'm changing level to subscription type, free or paid. And then once I'm happy with my data set, I want to actually push that out to Azure SQL Data Warehouse. In a real world, there'd probably be a lot more data processing ETL type activity in the Databricks site and Jupyter Notebook. But this is a fairly simple demo, just to give you an idea of what's possible. So blob storage parameters, what I'm doing here is just passing the credentials through, the access key. I've set up a blob store in Azure, and this will actually, it takes a data frame and it puts it into blob temporary storage. Data Warehouse then reads from that blob temporary storage into SQL Data Warehouse and persists that as a table. So let me just run this.
Remember not to change your key afterwards, since you have shown it to them.
Yes. Otherwise I might get some interesting things appearing.
Yeah.
Okay. Yeah. And then I must remember to remove this as well. Okay. So this is my SQL Data Warehouse configuration parameters. I'm passing through server, username and password. As I said, typically you'd store username and password in a security vault like Databricks Secrets with Key Vault. I'm providing my ports. And this is providing the credentials that I want to use to connect. Let's run that. Okay, all is good. And finally, the key step to this is really loading the transformed data set into a table. So this is how the data is actually written back to SQL Data Warehouse. And you can see here the temporary DIR location and the data warehouse URL. So let me just switch to, so Azure Data Studio, really nice environment for connecting to SQL instances, Azure SQL Data Warehouse, Azure SQL Database. As you can see here, I'm connected to my Azure SQL Data Warehouse. I have a database called Ignite, and in that I have a bunch of tables. All's good. So I'm just going to push this, what shall I call it? I'll be creative and call it table 4. So let's see, table 4. So let's just push this data set out now. Okay, that took 3.8 seconds. That's good. Let's see if we've got a table in here now. Yes, table 4. Right, so let's just make sure that works. What I love about Data Studio is IntelliSense in it. It's cool. Sample table. It's not quite refreshed yet. Sorry.
Top 100.
Yeah, thank you. Let's do 10.
Sample table.
Sample table, thanks. Always helps when there's 50 more eyes looking at this. Thank you. Right, so the scenario was taking the data frame and in a JSON file through Databricks, processing it, and pushing it out to Azure SQL Data Warehouse. So now someone could plug on Tableau, Power BI, and consume this as many times as they wanted. So we've also added streaming support now. I haven't got a demo for that, but go and take a look at the content. So you can actually do streaming into Azure SQL Data Warehouse as well, which is really cool.
So what Ben has shown you is now one way that we see and that we are creating ETL patterns for customers, where you want to offload the transformation from your database or your data warehouse and do it outside and not use a normal ETL tool like SSIS. So why would you benefit from this? Well, in a lot of cases, when you have the new data sources and data types, I mean, you saw how easy it was to work with a JSON object, and that gives you different capabilities. Anything where you need to do string manipulations, that is quite, it's like the tools for normal ETL tools are not that optimized for it. They are optimized for how to move relational data very fast through a pipeline. While here, if you have new types of data sources, as Ben shown, you can do it very fast and efficiently in a tool like Databricks. And of course, you would schedule this as a job.
Yes. So ultimately, to productionize, you take the notebook and schedule it as a job to run whenever it's required.
Question?
I don't work in this normally, but we're getting ready to go to big data. So I guess what I've seen there is you had these multiple databases, and you were able to go in here and pull specific tables from whatever database that you had, right? And then you just generated a new view or a new query, essentially. I mean, that's what I saw.
Yeah.
I'm not a DB expert.
So yeah, ultimately, took a data file, processed it in a pipeline, and persisted that to the user in a table. That's the
Example would be if I'm going to have multiple data sources, right? And I can't get this data into one place to smartly make some type of decision on maybe an asset or something that's out there that I need to know about, right? So I have these multiple analysts out here doing all this work, but yet I left them with rights to it. So with this type of application, I can come in and query those multiple databases that have been submitted, the records that have been submitted,
Yep.
and kind of bring them under one umbrella.
Yeah, so to rephrase the question for everybody to hear, so can I connect to different data sources and basically ingest all the information into this environment and then persist the results? And the answer is yes, you can. So as you see here, Ben defined one connection to, in this case, an Azure Blob Storage. What you could as well do is have several connections to other data sources, bring everything together, join it, do the data manipulations, and then persist the results. So yes is the answer.
Specific columns
Exactly. Pull specific columns from different sources. True.
Great question. Thank you.
Thank you.
Just finally, I've got one more demo, which I'll run through quickly. So what I like about Databricks is the flexibility it gives you. So I thought, can I consume tweets just to look at what people are saying about Ignite? So in terms of setting this up, let me just see. I had to import a couple of libraries from the Maven library. So I've got the Event Hub library, first class adapter, Twitter adapter loaded. I had to create a dev account on Twitter, obviously, which took about 24 hours to be approved, which was pretty straightforward. But then I thought, yeah, let's look at what people are saying about Ignite. So this was quite funny last night when I was looking at the party and what people were saying. It's like, who's got a pass for the party? So, yeah, as you can see here, so these are just some of the tweets from last night. But let me just clear this to give you an idea of what's happening here. Okay, so what I've just done is set up another storage area and an event hub and a policy with a key. So again, I must delete all these resources later. Within the body, I've actually put my Twitter keys, so tokens, OAuth tokens. Sorry, my mouse is not working very well. And then here I'm just looking for Ignite tweets, okay? So pretty straightforward. So let me just clear that again. Sorry, it's case sensitive. Oops. Okay, that's all good. Hopefully that's gone. Okay, so if I just execute this now, hopefully the gods are with me for demos. I should start seeing tweets. Oh, okay, here we go. So we're starting to see some come through now. LinkedIn integration. So what you'll see here is real-time sentiment and tweets coming through. I've got another Jupyter notebook which actually does the sentiment analysis on the tweet. So what that uses is the Cognitive Services Text Analytics API over the stream and gives you the sentiment in the terms of a scale of 0 to 1, negative to positive sentiment. So this is another scenario. This is quite interesting in terms of consuming real-time data sources, analyzing it and getting an idea of the sentiment of that. So let me just stop this execution. I'll share the code samples and things after the event. Okay, so let's switch back to...
Yeah, so that brings us into architectural patterns. So it's like what an architectural pattern is something that, an idea that can be useful to others. The most common one that we see from a pattern perspective is what's called Lambda. So Lambda, it's an architectural pattern where you have basically the ability to consume or to handle both streaming as well as batch data. And you do it in 2 different layers. So in this case, we have a speed layer that receives the streaming information like Ben showed. We have a batch layer that handles the batch data. And we have a serving layer which exposes the batch data. And then you can query across both of them. So how would you implement this in an Azure scenario? So as Ben showed, was exactly that. So Ben had an event hub. The event hub received the streams coming from Twitter. He then had Databricks as the speed layer, consuming those from event hub. And he ran a query on top of the stream. What you also could do is you can actually then have Databricks persist the tweets as they come in as well. So not just query on top of the stream, but also persist it down into Azure Data Lake Store. Azure Data Lake Store, in this case, being part of your batch layer. So you have your batch-oriented architecture, where you get data from business applications, and you store it in Azure Data Lake Store, and then you use Azure SQL DB as a serving layer. Now, what you have the possibility to do then is actually have your applications now query across both the stream as well as the batch data. So how do we then see these patterns being put into practice in the different scenarios? So as we've shown you in the first demo, one of the key things that we typically see is where you want to do ELT. So in this case, ELT, so extract, load, transform. In this case, we have Azure SQL Data Warehouse as our only compute engine. So your questions, I think it was you that asked the question, would Azure Data Lake Store be part of an architecture? Yes, in this case. Because what we're doing here is we are now feeding data from the different sources in the raw format into Azure Data Lake Store. So basically, we are using that as our staging area.
Okay.
So.
That was something I was wondering about. So back when I asked earlier, it was said, no, you really wouldn't use Data Lake Store. I guess I apologize for not following. What's different now that we do want to use Data Lake Store?
So that is if you are using, so the difference here is if you would be using the normal ETL pattern, like you would have SSIS extract the information, you typically would push it directly into the database.
Okay, so SSIS, we can talk about this later.
Yeah.
Push them up to later, that's fine.
Yeah.
We don't use it.
Now, in this case, we're not using SSIS. Here we are doing ELT, so the processing is done by the database. So you run stored procedures, basically, that ingests the information from Azure Data Lake Store, and there you do the manipulation inside the database. So why would you do this? Well, if you're a SQL developer, it's really easy to do it. I mean, everybody knows how to write the stored procedure. The other pattern that we see is the modern ETL pattern, which was the pattern that Ben showed last in the demo. So in this case, we are still extracting information from the source systems. We're pushing it into Data Lake Store, but we're using Databricks as our transformation engine, much as like Ben showed. So push it into Data Lake Store, and then use Databricks for the data processing. As we said, so to your questions, can Databricks connect to other data sources? Yes, in this case, you can see that it connects to SQL DB down at the bottom directly. So there, we're not consuming or storing it in Data Lake Store. We're doing the data processing, and once we have done the data processing, we push it into Azure SQL DW. That will be the serving layer for our queries. So these are the two most common patterns that we see and that we are implementing with customers today. They do allow for infinite scalability. It's like in the modern data warehouse world, you can do both ETL and ELT in a very efficient manner. When should you use one or another? Well, in this case, where you have a lot of non-relational data sources, the ETL pattern using Databricks is really a good fit because SQL as a language is fairly limited to doing a lot of transformation across non-relational data sources. So, learnings that we have had. So key thing is, it's like when you're using Azure SQL Data Warehouse, you have to remember that your tables will be distributed across the nodes. And they will be distributed based on a hash function that you define on a column. So you really, really need to choose your hash column wisely. Because it may end up that you end up with a data warehouse that looks like this. So you have everything ending up on compute node 2 on the screen here that you have on your lower right-hand side. That is a frequent reason for bad performance. So when could this happen? Well, distribution on date is probably not the best idea for a number of reasons. Because you will have some dates that will have more transactions than others. So you would get skew. You typically also would query on the latest date, which typically would end up in the same distribution. So you would have a hotspot on that side. Other things could be like doing it on a surrogate key that is a big int. Not a good idea either. So choose your partition distribution column wisely. The other thing is SQL Server Data Warehouse has this great feature called Polybase, which allows you to do the ingestion from Data Lake store. Don't try to, so what you do is you create an external table and you then can query. Don't leave your data there. Use it for loading. I had a customer walk up to me yesterday in the booth and said, we tried this Azure SQL Data Warehouse and we were using external table all over the place and it was very slow. And yes, because that is not what it is meant to be. It's not meant to be used for querying. Now that may change with SQL Server 2019 and the enhancement that they've done in Polybase. The other thing that you should think about is you have the possibility of also using partitions in combinations with distributed tables. And it's a very good thing because what it allows you to do is rebuild statistics on a specific partition, rebuild indexes on a specific partition. You can manage your database in a good way. Don't over-partition, because that is a common reason for getting bad performance as well. The other thing is, if you're doing joins between two large fact tables, make sure that they have the same distribution key. Because if they don't, you would actually move one of them to every data node to be able to make sure that the join works. And that could cause enormous performance issues. So make sure that you monitor that. So skew, statistics, and data movement. Those are the three things.
Just quickly, or briefly, because I'm conscious of time, we'll go through a few performance considerations on Databricks and HDInsight as well. So these are learnings that we've seen from the adoption and usage of Databricks around the globe. So landing data in blob storage and making sure you partition that correctly. So don't just put hundreds of thousands of files in one container. It's better to partition it out. So you need to think about your partitioning strategy. Simon's actually going to talk about that briefly on Azure Data Lake blob storage optimizations. Use Delta. So if you're not familiar with Delta, go and have a look at it, but it's got a number of optimizations for file systems. If you can't use Delta, use Parquet files, which are quite common file format. Use small files, so typically in the range of hundreds of meg to 1 gig is the kind of sweet spot. So think about that as well. And also talking about the security and the policies, making sure you don't embed usernames, passwords in Jupyter notebooks and using secrets. So you can use Azure Key Vault or the Databricks backend for that. So you've got options.
Don't use too small file sizes.
Yes,
either.
sorry.
Because if you use too small file sizes, you would get a massive overhead of handling the files. So 100 megs would be what you would
Yes.
try to get to.
On HDInsight, so when you're spinning up a HDInsight cluster, think about the number of head and data nodes and the specification. So going from low-scale, low-cost VMs up to 0.5 terabyte of memory and multiple cores. Think about the quota capacity. So there have been occasions where we've wanted to create HDInsight clusters, but we've hit the core capacity of the Azure subscription. So that involves a call to support to say, remove the cap or increase my capacity limit. So think about that in the modern data warehouse scale-out world. Also think about peripheral costs, so things like the VNets AD when you're looking at capacity requirements and budget constraints. And I talked about this briefly earlier, the simulation framework. So this is the Hive test workbench, which is being used, really useful for doing some capacity planning on HDInsight. So take a look at that as well.
So when we look at the different things around it, file format becomes very important as well. So me and Ben, we were involved with a large case a number of years ago where we did HDInsight, and this applies to all of HDInsight and ADLA and others as well, is that the different file types has a big impact on your performance. So in that case, we got data in CSVs. And of course, I mean, we could query against the CSVs, but as you can see, the query time to scan was extremely large when we used CSVs. The file size was large, so we paid for storage. So what we did and implemented there was the first step in our pipeline was basically just to load the data into, in that case, an ORC file. So we got the data as a CSV file, we ran a query, basically persisted the data as an ORC file, and dropped the CSV file. Because that then gave us the possibility of any other queries that came after that was like 100 times or 1,000 times faster than the first one. So that is something that you could that you need to think about. What data format? Now the big question is what determines your data format? Why don't you choose ORC or Avro or Parquet all the time? Well, in some cases, there may be people that want to use tools that can't consume those file systems. So you end up back with CSV as the most common format. The other thing is plan your storage. And the reason for that is you need to plan for versioning. You need to plan for partitioning. So partitioning in the big data world is basically different folders. So in this case, I show you something that I did for a customer where we were ingesting data from IoT devices. So in this case, we had the root folder. We then decided that, okay, we will have two folders, one for the raw information because we wanted to store that, one for the transformed information, and a third one for the results. So in this case, you can see that we did go from raw. We then had a folder that decided, okay, was it something that was public for consumption across the organization, or was it something that was restricted? We then went into looked at, okay, so what process function is it? So could be like things like, this is a data set that is owned by HR, or this is a data set that is owned by the sales team, or by the services team. And then we basically went down to the actual function that we had. So that could be the table, which was the source data. And then it's like what type of data that we had, because sometimes we can have in different data format. And then partitioning based on the year, month, day in that case, down to the individual files. So think about how you will actually ingest it. Try to think about what will happen if you would change the data source, so the format would change. How would you take that? Think about how you would do these types of thinkings when you plan for it.
So what I hope you realize is that there's a lot of decisions and a lot of choice, and a lot of it is driven by the use case and organizational considerations around internal skills and readiness for modern data warehousing. So what's the best path for you? So what we've tried to do here is actually condense some of this information and put it into a tabular structure with some decision points and trade-offs. So this is still evolving as things change. But what we've tried to do here is condense that and give you a picture of what can I choose and what are some of the key points I need to consider. So things like the languages to be used, the security requirements, the scale and the cost considerations. So I won't talk through all of these pillars on here, but the slide's available and you can use it. Hopefully it's going to be useful to you. One of the key things is the kind of, what you'll see here is a lot of this is schema on read in terms of the scenarios, and it's only the schema on write supported by Azure SQL Data Warehouse today. So common themes and feedback we see. Next slide, please, Simon. This is pretty much the last slide, so thank you for sticking with us. So data trends, there's less concern actually around data quality. So a lot of the times it's just give us all of the data and we'll process it and get insights out of it ourselves. And the freedom to integrate and combine multiple data sources. So it's almost like there's a citizen data science culture going around where I can just connect to external data sources and bring them in and process them. A lot of the considerations are also around the organizational capability that we talked about. So adopting cloud and Azure Data Warehouse and analytics, you need to think about COE functions or information management capabilities within your organization. So we're often asked about, can you come and help us define and establish and set up a competency center for cloud analytics? Think about your budget and forecasting model in this new world. So how do you take that from doing a POC and evolving that to, I need to know what to request for Azure services on a yearly basis? And also, what's the ALM DevOps type approach in modern data warehousing and AI world? So what does the end-to-end pipeline look like? How do we need to understand what skills, disciplines we need to get the data scientists through and the operations support through? And start with the use case, really important. We see a lot of failure when we're starting from bottom-up technology conversations. Always need to start from what's the outcome and the business use case, and that will drive the blueprint and the architecture of what you're trying to do. And I find it really quite nice in the fact that we have all these kind of semi-structured data sets like JSON and XML, and ultimately at the end of it, we're still trying to put tables over it in the data warehouse. So that's quite nice to see, actually.
So some key takeaways. So plan your data strategy. Use use cases to drive it. Don't sit down and dream up an architecture that is the perfect architecture from an architecture point of view. Think about how it will be used. When you choose the service, make sure that you choose the one or several of them that fits your organization, your use case. The other thing is cloud is actually the obvious choice. The reason for that is the accelerated business. I mean, we can get a Databricks cluster, a data warehouse up and running in minutes, as opposed to wait for 6 months to procure a server. That means that you can do tests. So in a lot of cases, you don't need to go through scenarios where you need to do like this RFP, POC, MVP type of procurement, where you need to test everything because doing the actual procurement is very expensive. Test it, run it for a week, turn it off, throw it away. You paid for a week's consumption. And the other thing is technology is just part of it. So it's like that's usually the most easy part. The bigger problem is around people and processes. Like it took me with one client, it's like 6 months to open a port to the internet. So that's sometimes a process issue.
Yeah. Thank you for sticking with us. Reached the end. Got a slide in here with email addresses. Simon doesn't get enough emails, so email Simon. Thanks very much for sticking with us.